Okay, so today we're going to finally start taking a look at working with microcontrollers. And so this right here is the one that we're going to use. This is called the Raspberry Pi Pico W. And so it's made by a company called Raspberry Pi. And they are initially made basically kind of like some really small like computers called the Raspberry Pi. And they've done that for probably about like 10 to 15 years, and more recently, they started producing microcontrollers, which is what this is right here. So this right here is the microcontroller. It's called the RP2040, and this is kind of the brain of this chip. And this is like a programmable little mini, I guess we'll call it like a robot brain. So if you think about all the things around your house and in your car that have that are run on electricity, many of these things are going to have some kind of control circuitry inside of them. Not all of them, but many of them will. And of those things with the control circuitry, many of those are going to have a programmable like microcontroller in it that's kind of running the show. And so this is an example of one. There's many different types and brands, and there's entire, there's so many different microcontrollers out there and so many different like ones you can use, and often people will select them for like cost or for size or for memory and stuff like that. But this is the one we're using. There's a couple reasons I like this. So this particular board, the Raspberry Pi Pico, and this in case the W, is fairly low cost, and it has a lot of memory. So we have 2 megabytes of flash. So this is a little flash chip, and so your computer probably has something like anywhere from 256 gigabytes to maybe like 2 terabytes of storage. This has 2 megabytes of storage, and so storage is important for us, because that means how much code we can put on there. And it also has a lot of RAM. So this particular chip has 264 kilobytes of RAM, which is a different kind of memory that's for basically how much information it can work with at one time. And previously, when teaching this class, we've used a board called the Arduino Uno R3, which has something like, I think it was 8 kilobytes, maybe it was like 16 kilobytes of RAM. And so we have basically a lot more RAM on this, and allows us to, I think, 16 times? Let me do the math real quick. Yeah, just about 16 times as much RAM on this. And so that allows a lot more flexibility, and in particular, so what we're going to be doing with this is we're going to be programming it using Python. And so in order for us to program a board using Python, there has to be a program on here running the Python interpreter, and then we interact with the Python interpreter and run those files. And so in order to do that, we have to have a lot of RAM, and it has to be relatively fast chip as well. And so this is if I rotate the screen, you'll see all kinds of stuff about it, and you can look at those things later if you want. But this is relatively fast. It runs at like where's the speed here? The clock speed. I don't see it right now. I'll go back and find it. But this is fast enough and has enough memory to run the Python, and so we're going to be using it to program with Python. In the past, the boards that I've used just didn't have enough RAM on them to run Python, probably not enough flash as well, and didn't run fast enough as well. And so I'll go over, just to review some of the components on here. So if you look at this from the top, this is the top side of the board, this is the bottom side. You can see that there's labels on the bottom for each of the pins, which is convenient, except that when we use this, it's going to be sitting on a breadboard like this, so we can't actually see those pin labels when we're using it, which is unfortunate. And so because of that, you're going to have a document like this, a piece of paper that labels those pins for you. And so we'll talk about some of the most important ones. But before we do so, we'll just talk about some of the components on here. So as I mentioned, this right here is the main brains behind the operation. This is the Raspberry Pi, or the RP2040. down here, inside this kind of like metal casing, is another like microcontroller that is going to run Wi-Fi and Bluetooth. And so this board is capable of Bluetooth communication and Wi-Fi communication, and we'll be using both those things, primarily the Bluetooth. We'll control it like with a phone, or like another board. And then this area right here is the antenna. This is the Bluetooth and Wi-Fi antenna. So we have a Bluetooth control here, capabilities here. We have the antenna for the Bluetooth and the Wi-Fi right here. Right here, this is the flash. So this is where when we write code and save files onto it, this is where those files are going to live. And then right here, this is how we communicate with it. So this is a chip that communicates. It takes the signal from the USB and converts it into what's called a serial signal that we get to the board. And when the board sends us messages, or when we save files to the board, things like that, it's going to be communicating through that chip right there with the microcontroller. USB uses 5 volts, and so we plug in a 5-volt USB cable. This is a micro USB port, and so that USB cable is going to have 5 volt and ground on it, and it's going to take that 5 volts here, and this is going to drop it down to 3.3 volts. And so this chip here runs on 3.3 volts. And so we have to take that 5 volts from the computer and drop it down to 3.3 volts. That's what this little component here does. It's called a regulator, I think there's a linear regulator, and it's going to basically take that 5 volts and drop it down to 3.3 volts. Okay, and those are the main components I wanted to look at. I think we'll show one more thing. So this little thing right here is the crystal. So this is basically the clock that basically keeps track of like time for it, and that's important because it controls kind of the speed at which it operates. And then the other thing I want to mention is this button right here. We won't use it too much, but anytime we need to like re-put MicroPython on there, we'll use this button in a specific sequence to do that. Okay, then we've got a little LED right here that's built in, and we can make that LED blink, and we'll learn how to do that down the road. Okay, and so this is the basic overview I wanted to show you. We're going to switch over now to this other graphic. You're going to have a copy of this. Maybe it's going to be cropped a little bit, but this shows essentially the layout of the pins on the Raspberry Pi Pico. So you can see these little circles on the side, and these are ways to access the pins or the connections on this microcontroller. So if we look at the picture right here, you can see these little dots on the outside, right, and those little wires coming off of them, and they're running off to each of these pins. And so what this thing can do is it can turn these pins on and off like switches. All right, it can set it to high, so like it would be 3.3 volts, or set it to low, which is ground or 0 volts, and it can turn that on and off. And so you can use it to control something and to turn something on and turn it back off like programmatically. Okay, additionally, it can use these as inputs, and so it can also reverse that. And so instead of using this to control something, it actually can do like a voltage reading on this pin and check to see if it's turned on or off. And so if we have like a button connected to it and you press the button, it's going to change the state of the pin, and then you can check to see if it's turned on or off. And so it can do that as well. And so these pins, you can see they all kind of map back to the microcontroller here. And so they have labels, and so we call this one GPIO 0, GPIO 1, and then you can see this is ground or 0 volts, right? We have a bunch of ground pins all labeled in black. Okay, but we have something like 28 general purpose pins, or GPIO is what we'll call them. They're labeled here GPIO. They can also be used as something called PWM, which we'll learn about later. You can see that each pin has like multiple labels because it can be used for multiple things. So this is called SPI, this is called I2C, and this is called UART. We're going to maybe use these things sparingly, but for the most part, we're going to be focused on using them as GPIO. And then we've got over here some special ones that can be used to do analog readings. Okay, and so this is when something is, we want to read if the voltage is anywhere between 0 and 1, and so we have some additional capability there. So that will be important for us as well, and so we have 3 of those. So that's the one kind of downside of this chip is there's only 3 analog inputs. Previously, working with Arduino Uno, we had, I think, 6 of them. Let's see, anything else that we should mention here? There's 3 pins here in the middle. These are used for using like a software or like a hardware, well, basically a special piece of equipment for programming it and potentially debugging it. So if you are writing code in C or C++, which you can do on this board as well, and you want to kind of step through your code, that's what these are for. This is not something we're going to be worried about. And let's see, is there anything else that will be relevant to us? I think that should be enough to get us going. And so when we use this, there's going to be pins soldered into each of these, and it's going to be connected to a breadboard like you can see right here. Okay, let me close this down. And so this is what our setup looks like. And so I provide you with 2 breadboards. So this Raspberry Pi Pico is connected to a breadboard, and then this breadboard is connected to, you can connect into the breadboard to do all kinds of things. And so we have a second one here because this takes up most of the first one. So you have a second one to wire up your circuits. You can put buttons on there. You can put LEDs on there. We'll do all kinds of things and put all kinds of things on here.